Welcome back, guys. We are still on the special types of linear programming problem, and in this video we'll be doing the maximal flow problem. In the maximal flow problem, we consider a network that has n nodes, which consists of the source node and the sink node. And for convenience, we label the first node as the source and label the last node as the sink. But before we continue, in the previous video we did the network and the graph, and it was just theories, but in this video we'll be dwelling on the maximal flow problem, and this consists of a network. So if you've not watched the previous video, please do well to watch it and then come back to this video so that we understand everything we discuss here better. Right here on the board we have a network, and this network has 6 nodes. This is 1, 2, 3, 4 and 5 and 6 nodes. And in the previous video, we discussed that we can use a network to represent a highway road. We can use it to represent a pipeline. We can use it to represent an electrical distribution. So let's just assume that the network we have here is an electrical distribution, where we have the points where these cords are connected. Now these lines, let's call them cords. So or cable that are connected to these places, and then the capacity of this cable is 9, and then this cable has a capacity of 8, and then this has a capacity of 4, and so on. And the maximal flow problem is, what is the maximum amount of flow that will pass through this network so that we go from the source node down to the sink node without having any issues. So if we decide to go through a path, let's say we go through this path, we go from 1 to 2 and from 2 to 4 and down from 4 to 6. If we go through this path, if we just pick this path and then check the maximum amount of flow or current that can pass through this place to get to this flow that can pass from the source down to the sink, just using this path. If we want to know the maximum amount of flow that can pass through this place, we check the capacities of the cables that are connected to down to this place. So if a capacity that goes of the cable that goes from 1 to 2 is 9, and the capacity of the cable that goes from 2 to 4 is 4, and down to 6 is 5. Now, if we go through this, we find out that if we pass anything greater than 4 through this path, we'll have a problem here, because anything greater than 4 will not pass through this line. Why? Because this cable has just a capacity of 4. So when trying to know the total amount of flow we can pass through this network, there are two ways that we can find this solution to this problem. The first way is to go through all the paths that will lead us from the source node down to the sink node, and then check the maximum amount of flow we can pass through each of them, add them up together and get a result. But that does not always give us the maximum flow. So we are going to be doing that, and another way of solving this problem is using the label algorithm method. We'll first go through all the paths that will lead us from the source node down to the sink node, calculate all the flows that we can pass through the different paths, and then get our results, and then we try to see if we can modify it before we go into the labeling algorithm. So how do we do this? We just pick a path that will lead us from the source node down to the sink node, and then check the maximum flow that we can pass through that path, bring it out, and then subtract it. So before we continue, I would like to just draw. I would like to duplicate this drawing so that we'll see how this we solve this problem. Right here, I just made a duplicate of this network, so that to be easier for us when we are solving it. You don't have to do this before solving this type of problem. So we start doing this by picking the paths that can lead us from the source node down to the sink node. And one of those paths that can lead us right from the source node to the sink node is this. We can decide to go from 1 to 3, and then we go from 3 to 2, and then we go from 2 down to 5 or down to 4, and then we go from 4 to 6. So if we check this part, let me just write it out. We have 1 down to 3, down to 2, down to 4, and to 6. So the 6 is the sync node. That's where all the arrows are pointed, where it has all the arrows connected to it, pointing to it, and then the source node has all the arrows that are connected to it, pointing out from it. So in this case, if going from 1 to 3, the cable has a capacity of 8, and then from 3 to 2, the cable has a capacity of 2, and then from 2 to 4, it has a capacity of 4, and from 4 to 6 has a capacity of 5. So in this part, what is the maximum amount of energy or flow that can pass through this part? And then we find out that the maximum we can pass through this place is 2. Reason being that whenever, if we pass anything greater than 2, once it comes to this plate, we take only 2, and then that's what we get to this point. So since we pick 2 as our maximum flow for this part, we write it out here as our F1. That is the first flow that we pick. So our F1 is 2. And then after getting the F1, we subtract 2 from each of those parts that led us to this place. As in from this part that led us from the source node to the sink node. So the maximum flow that we can pass through this place, we subtract it from it, and then we get our new network flow here. So I'll just do that now. Right, going from 4 to 5, I mean from 4 to 6, we have the capacity of 5. If you subtract 2 from it, what will be remaining there is 3. And then from 2 to 4, we pick that, we subtract 2 from it, we have 2 remaining there. And then from 2 to 3, I mean from 3 to 2, we have the capacity of 2. And so subtracting 2 from it will make it 0. And then from 1 to 3, we have 8 minus 2, which is 6. After doing this, we find out that we can no longer pass any flow from this cable. So we just make a mark here so that we'll just know that we are no longer going through this place. And then we find other parts that we can go through from the source node down to the sink node. And but before we do that, we write out the remaining capacities that we didn't pass through. So right here we'll have 9, and here we'll have 4, 2, 5, and 6. So after doing that, we find another part that can lead us from the source node down to the sink node. And then let's go through, if we go from 1 to 3, and then go from 3 to 5, and then go from 5 to 6. So if we pick this part, we will have we'll have 1 to 3, 3 to 5, and then 5 to 6. So right here from 1 to 3, we have 6 capacities here, and then from 3 to 5, we have 5, and then from 5 to 6 has 6 capacities here. So the maximum amount of energy or flow that we can pass through this node, I mean this part, going from the source node down to the sink node, is 5. Why? Because this is the smallest capacity that we have in this part. And so write our F2 as 5. So we'll have F2 equal to 5. And then after writing it out, after writing our F2 as 5, we subtract 5 from this part that we went, so that we get the new network. So let's subtract 5 from this place. We have taken out 5 from this, we have 1, and then from this place 5 minus 5 is 0, and then here minus 5 is 1. And so we write out the remaining places that we didn't pass through. We have 9 here, 9, 0, 4, 2, 2 here, and then 3. And so this is our new network. And we check if there's any other path that can lead us from the source node down to the sink node. For now, this cable have been we have passed through this cable, and we have used up the maximum flow that we can pass there, and right here also. And so we check which other path can lead us right from the source node down to the sink node. And we see that we can go through this path. We can go from 1 to 2, and then from 2 to 4, and from 4 down to 6. So we check through this place, and then we see going from 1 to 2, 4, to 6. What are the capacities there? From 1 to 2 is 9, and then from 2 to 4 has the capacity of 2 remaining there, and here has 3. So the maximum flow that we can pass through this part is 2. And so we have our F3 as 2. So we continue like that until we are no longer able to go from the source node to the sink node. So F3 is 2, and we subtract to get the new network. So subtracting 2 from here will be 1, and then right here we'll have 0, here we'll have 7, and then the rest remains the same. So we have 1 here, 0, 4, 2, 0, and 1. So remove the lines that we can no longer pass through, so that we will not make a mistake. So right here we have these, but we can still go through some other paths to get to 6, which is the sink node. So we can decide to go from 1 to 2, and then we can go from 2 down to 5, because we can no longer go through this place, and then from 5 we go to 6. So going through that route will give us from 1 to 2, from 2 to 5, and from 5 to 6. Sorry. So right here we'll have 7 as the capacity, and then from 2 to 5 we have 4, and right here we'll have 1. So the biggest the biggest amount of flow can pass through this part is just 1. So we have our F4 to be equal to 1, and then we subtract 1 from this flow that we just went through, like this, and then we get our new network. So I'm going to wipe this place off, and possibly this side too, so that we'll be able to finalize. I'm just going to leave this, and then till we get to the last network, we are going to subtract 1 from this part that we went to. So we went from 5 to 6, so we subtract 1 from there, and we'll have 0 here. And then we went from 2 to 5, we subtract 1 from there, 4 minus 1, 3, and then from 1 to 2, 7 minus 1, which is 6. And then we write out the remaining capacities just the way they are. We have 0 here, 1, 2, 0, and 1 here, and 0 also here. So, and then we pick out the places that we have 0. Right here, we can't pass through this place again. We can't go through this path, and here. So what we just have left is just this. Now we try to see, is there any other way that we can go from the source node down to the sink node? And I think we can go from this place, can go from 1 to 3, and then from 3 to 6. So let's do that. Go from 1 to 3 and 3 to 6. We have 1 and 6. Now from going from 1 to 3, we have just one capacity there, and then from 3 to 6 we have 2 there. So the maximum that we can pass through this part is 1. We'll write our F5 as 1. So we subtract the fifth flow from the part that we just went through, and then right here we have 1, and here we have 0. And so we write out the remaining. We have 0 here, 0, 3, 0, 1, 6, and 0. So we remove this part here, 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 and here. And so we find out that there is no other path that can lead us from the source node down to the sink node. And so we add up the flows that we have. I wrote out the ones that we did, so I cleaned it and wrote it out here. So right here we have the first flow is 2, the second is 5. We have 2 again, 1 for this, and then 1 for this. So adding these flows together, we have 2 plus 5, which is 7 plus 2, 9, plus this will give us 11. So the total amount of flow we pass through this network is 11, but that might not be the maximum amount of flow that we can pass through this network. So we are going to start from the beginning again, and check if there are any other paths that we should have followed, which will give us something bigger than this. Right here, we still have the same problem, but we'll be solving it the same way we solved the last one, but we'll be going through different parts. So we'll see if going through different parts will help us to increase the maximum, the number of flow that will be able to pass through this network. And so let's try if we can. Let's go through this part. Let's go through from 1 to 2, and go from 2 to 4, and from 4 to 6. So if you have this, the capacity here is 9, and then the capacity here is 4, and here is 5. So the maximum amount of capacity that we can pass through this part is 4. So have our F1 here as 4, and then after getting the F1, we subtract it through that path that we went through. And so right here we'll have a new network. So 5 minus 4 here will be 1, and here will be 0, right here will be 5. And then we'll write out the rest the way they are. We have 2 here, 8, 4, 2, 6, 5. And then we check which other routes can we go through. We can go from 1 to 2, 2 to 5, and 5 to 6, or we can decide to go from 1 to 3 and 3 to 6, whatever way we wish to go. So let's go from 1 to 3, and from 3 to 5, from 5 to 6. So if we decide to go this way, we'll have 1 to 3, 3 to 5, and from 5 to 6. So right here we'll have 8 as the capacity. From here we have 5, and right here we'll have 6. So the maximum amount of flow we can pass through this part is 5, which is the smallest capacity in that part. So right here we have our F2 will be equal to 5. And then we check if there is any other, we subtract 5 from that root and then check if there is any other path that can lead us from the source to the sink. So from this side we subtract 5, here we'll have 1, and here we'll have 0, and right here we'll have 3. So write out the rest: 5 here, 0, 4, 2, 1, we have 2 here, and we check which other path that we can go through from the source node down to the sink node. So we have already taken out everything that we have here and here and here. So we can't pass through, we can't go from 2 to 4, and we cannot go from 3 to 5. So we check which other routes can we pass through here. We can go from 1 to 3, and then from 3 to 6. So let's see, we have 1 to 3 and 3 to 6. And the flow there, we have 3 here and we have 2 here as the capacity. So the flow there will be 2, because that's the smallest flow that we can have there. So we subtract 2 from that to get the new network. So we have right here we have 0, and here we have 1, 1, 0, 0, 4, 2, 5, and here we have 1, 2 minus 3 minus 2, which is 1. After writing this out, we check if there's any other path that can lead us from the source node down to the sink node. And right here we still have, we can go from 1 to 2, from 2 to 5, and then go from 5 to 6. So we have 1 to 2, 2 to 5, and from 5 to 6. So from 1 to 2 is 5, and then from 2 to 5 we have 4 here, and here we have 1. So we pick the smallest among the capacities, and that's our F4, and right here we have 1 here. So I'm going to wipe off this place, and then let's see if there is any other path that we can go through. Subtracting 1 from the paths that led us here, we have this, from 2 to 5, and from 5 to 6. So subtracting 1 from 5 to 6 here will give us 0, and then from 2 to 5 we have 3 remaining here, and right here we'll have 4. So write out the rest. We have 2 here, we have 1, and we have 0 here, and right here we have 0 and 1. So we see that we can no longer go through this path here, here, and here. So we check, is there any other path that can lead us from the source node down to the sink node? If we decide to go like this, we can't go to this place, and then there is no other path that can lead us from the source node down to the sink nodes. And so we calculate the total flow that we have. Right here we have F1 is 4, F2 is 5, F3 is 2, F4 is 1. So we add them up together, we have 5 plus 4, which is 9, plus 2, 11, plus 1, which gives us 12. And so we have 12 here as the maximum flow that we can pass through this network. But in the previous one that we did, we got 11 from the same network, which means that this using this method will not always give us the accurate result. So we go into the labeling algorithm, which will always give us the maximal flow we can pass through any network. So we'll do this same example using the labeling theory. Right here, I have two diagrams, the big one and this. So before we start using the label algorithm uh, method, we should have something like this. So this is a D12 that is showing the direction of the arrow. Right here we have D12 equal to 9. We have D21 equal to 0. So we should have something like this. And this is just exactly the same problem that we solve using the former method. So, and this shows a type of excess capacity and the actual capacity that we are supposed to use to pass this code from this source node down to the sink node. So I'll be throwing more light on that after we finish solving the example, but because of how small the board is, I'm not going to be writing out all these things. We are just going to use it this way. I also want us to know that whenever we see the blue, the number written in blue barrel, we should just know that we are talking about the direction of the arrow that has the capacity, and then the one with the red will be the inverse direction. Before we continue, the previous method that we used, after getting a flow, we subtract it through that part that we got it. So but in this case, we are still going to be subtracting it from that part. But what we are going to be doing is when we subtract it from that part, from that capacity, we add it to this one. So I call this the excess capacity. That's the ones I will have here in blue barrel. And then this red ones, I call it the actual capacity. I'll still throw more light on that when I'm through with this example. So using the label algorithm theory, it says we start from labeling the nodes that are connected directly to the source node. So right here we have nodes 2 and 3 connected directly to the first node, which is the source node, and then we label them first. So how do we label them? We first go to the to this uh, to node 2, and then we check this node 2 is coming from node 1, which is the source node, and then we'll write it here, write 1 here, and then we write out the capacity, the excess capacity that is coming from node 1 to node 2. So the capacity here is 9. And so we go to the next node, which is connected to 1, and this is 3. We have here, we label here, and right here in 3, 3 is connected to 1, so write out 1 here, and then we check the capacity that is flowing from 1 down to 3, and that is 8. So we have 8 comma 1 here, I will have 9 comma 1 2. So after labeling the node that are connected directly to the first node, which is the source node, we go to the second node, which is node 2, and we check which nodes are connected to this node 2. We have the node 1 connected to it, we have node 3 connected to it, we have node 5 connected to it, and node 4 connected to it. But which node is it giving out capacity to? So in this place we have the arc directed towards 4, so it means that it's giving out to this 4. So we label 4 from node 2, and we check which other node is it giving out to. We have node 5 that is getting an arc from it, I mean a capacity from it. So we label 5 directly from 2. And so how do we label 4? Just almost the same thing. We have our brackets here, we write out 2 as the node right to here, and then For this place, we will not be writing this capacity, but we will be comparing this capacity that is coming from 2 to 4 with what we have right here. So right here we have 9, and here we have 4 as the excess capacity. So we compare the two of them and get the one that is smaller. That is what we are going to be writing here. So 4 is less than 9, and so we write 4 here. So I have 4 comma 2 here, and then we go to the next node. I'll label it from 2, which is because the arc is directed towards it, and here we are in node 5. So how do we label this? The same way we labeled node 4. We have it coming from node 2. We write 2 here, and then put our comma. We have capacity of 4 here, so compare it with this, the smaller one. We write it out, and we have 4 here. So we have succeeded in labeling all the nodes that are connected to 2, that are getting capacity from 2. So we check what is the next node that we are supposed to label other nodes from. We have labeled from node 1, and we have labeled from node 2, so we are going to label from node 3. So right here, node 3 has 4 nodes that is connected to 1, 2, 5, and 6. But it is given out to 2, this flow, and it can give out 5 to this, and it can give out to 6. But 2 have already been labeled from 1, and so we don't label it again. And we check from 3 to 5. 5 have already been labeled from 2, so we don't label it again. And so we go to the next one, which is 6. So we can label 6 from 3 because it's connected. So we go to this place. We have a bracket here, and then uh, we are labeling 6 from 3, so we'll write 3 here, and then we have 2 here, but we'll have 8 on that 3. So we'll compare the two of them and see the one which is lesser. 2 is less than 8, so we'll write it here. And the labeling algorithm theory says that once you label the last node, which is the source node, then you start doing the iteration. And how do we do this iteration? We go from the last node to the node that is connected to it, subtract this flow from it, and then go to the node that is connected to it and check the node that it has connection to, and then subtract 2 from it. And after subtracting you from the excess capacity, you add it to the actual capacity. So we are going to be doing that next. But before we do that, I'll pause the video and then draw this diagram again. Right here we have this is our last node, and we have labeled it. So we go from 6 to the node connected to it, that we got this capacity. So we have 3, and so we subtract 2 from it. So going backward, we subtract 2 from the excess capacity and add it to the actual capacity. So if we subtract 2 from here, we'll have 0, and then adding it to the actual capacity, we have 2. And then we get to 3, and then we check the node that is connected to it. We have 1 here, and then we still subtract the same 2 from the capacity, joining it to 1. So we have 8 minus 2 here will be 6, and then 0 plus 2 will be 2. Write out the remaining capacities that we'll have before we do the labeling algorithm again and again until there is no way we can label from the source node down to the sink node, and that is where we have our final solution. So let's continue to label. Yeah, right here we'll have 9, 4, 4, 5, 6, 5, and 2. So, and in this place we have 0, 0, 0, 0, 0, and this. So after doing this, we start to label again, and then 2 coming from node 1, level 2 from node 1, we have 1 here, and then the capacity is still 9, so we have 9 here, have 9 comma 1, and then uh, we label 3 from 1, so right here we have 1, and we just have 6 remaining here, so we have 1 comma 6. And then the next thing we label the nodes that are connected to 2. So we have 4 and 5, and then we label 4 here. 4 is coming from 2, and then you compare the capacity here with the one that is here. So right here we have 4 is less than 9. We label 5 also from 2. So right here we have 4 less than 9, and we now check after labeling 2, then we check if we check the for the we have labeled, so now we have succeeded in labeling all the nodes that are connected to 2, which is 4 and 5, and then we go to 3. Is there any node that is connected to 3? So right here we have 2 connected to it, but 2 have already been labeled, and we have 6 connected to it, but we can no longer go through this place because there is no excess capacity here anymore. So I'm just going to use the green biro and mark this place out, and then we check 5. We cannot level 5 because 5 have already been labeled from 2. So since we can't label any other node from 3, we go to 4. Can we label any node from 4? And see that 4 has a connection with 6, so we label 6 from 4. So right here we have 4 as the node that is given to 6, and then we check what do we have in the capacity here that is linking 4 to 6. We have 5 as the excess capacity, but what do we have on this place? We have 4. So right here we have 4, and then this place is 5. So we compare the two of them, we check the one that is smaller. So 5 is greater than 4, so we write 4 here, write the smaller capacity, and after that we start to so since we have labeled the sync node, we start to subtract this flow from the nodes that connect C's to this place. And so before we continue that, let me write out this. Let me write out our first flow 1, we have 2 here, and right here we have 4. Flow 2 is 4, and we start to subtract from the excess capacities, subtract 4 from the excess capacities, and add 4 to the actual capacity. So right here we have um, 4 as a node connected to 6. So and then we subtract 4 from the capacity, from the excess capacity. So 5 minus 4 will be 1, and then we add it to the actual capacity, which is written in red. So adding it to this, we'll have 4 here, and after doing this, we go to the next one, which is 4. Then we check which node is connected to it, 2. So they will label 4 from 2, and so we check the capacity there, and we subtract this flow from it. So subtracting 4 from here will give us 0, and then adding it to the actual capacity, we have 4, and then we go to 2, and we check which node did we label 2 from. We labeled it from 1, and then we check the capacity there, we subtract this flow from it. So right here we'll have 9 minus 4, which is 5, and then we have 4 down here. And so After doing this, we still write out the other capacitors that we didn't touch. So writing this out, we have 6 here, 5, 6, 0, and 4. Right here we have 0, 2, 0, 0, 2, 0, and 0 here. And after writing it out, we check if we can label from the source node down to the sink node again. And so we start our labeling again. We label 2 from 1 again. We try to label 2 from 1 again. So right here we'll have 1, and the capacity here is 5. 5 comma 1, and then right here we'll have 6 as a capacity and 1 as a node getting from 8. And then we try to see if we can label from 2. So going to 2, we try to label 4, but since the excess capacity now is 0, we cannot label 4 from 2. And so we go to 5, we try to label 5 from 2. So right here we have 2, and then we check 4 is the capacity here, and we check what is here. We have 5. So what is less? Which one is less? We have 4 as the one that is less than here. And so we have labeled all the nodes connected to 2. We try to see if we can label from 3. And we find out that right here we cannot label 6 from 3 because here is already 0. The actual capacity, the excess capacity is already 0. And then 5 have already been labeled. So we go to 4, but 4 have not been labeled, so we cannot label from 4. And so after that we go to 5. 5 have already been labeled, so we can label from 5. So right here, 5 is connected to 6, and so we label 5 from 6. We label 6 from 5. So right here we have 5 as the node here, and then we check the capacity joining 5 and 6 is 6, and we check the capacity that is labeled under 5 is 4. So we check which one is lesser. 4 is lesser, so we write it here. So right here we have 4, and then we do our iteration again. We subtract from the path that led us to the source node. So right here we have 4 minus 6 minus 4. 6 minus 4 will give us 2, and then we add it to the actual capacity. So I have 4 here, and then we check again. 5 is labeled from 2, so subtract 4 from here. We have 4, we have 0 here, we subtract 4 from 4 here, and then we have 4 as our actual capacity here, and then 2 is labeled from 1, so subtracting 4 from 5 will give us 1, and then adding it to 4 down here will give us 8. After doing this, then we write out the remaining excess capacities. Right here we'll have 6 and 2, 5, 0, 1, 0. And we also try to give a mark to the places that we cannot go through again. So right here we'll have this, because the excess capacity is 0 here, and right here the excess capacity is 0 again. You have this, and then that's it. So we try to see if we can label again. So right now we can label from 1 again. So we have labeling 2 from 1. We have 1 here, which is the node, and then the capacity here is 1. And then we try to label 3 from 1. Right here we'll have 1, and then the capacity here is 6. And so we try to see if we can label uh, any node from 2. So right here we have 0 as the excess capacity, so we can't label any node from 2, can't label 4 from 2. And we check here again, we cannot label 5 from 2 because the excess capacity is now 0. And so there is no other node that we can label from 2. We jump that and we go to the next node, which is 3. Right here we cannot label 6 because the excess capacity is 0. And we check 5 have not been labeled, so we can label 5 from 3. And so right here we'll have 3 as a node that is labeled, we are labeling 5 from. And so we check the excess capacity here is 5, but what is written under 3 is 6. So which one is less? 5 is less than 6, so write it out here. And then after doing that, we go to the next node, which is 4. 4 cannot label any node. Why? Because it have not been labeled. And then we go to 5. 5 can label 6. So we label 6 from 5. Right here we'll have 5 here. And then the excess capacity remaining here is 2. And we have 5 as the capacity under labeled under 5. So 2 is less than 5, so write 2 here. And then once we label the last node, we do our iteration again. So I'm going to wipe off this place and populate this side also so that to finish the iteration. But before I wipe off this board, let me write out the flows that we've used. Right here I'll have the first flow, which is 2. The second flow is 4. Right here I'll have the third flow, which is F3 is equal to 4. And here we'll have the fourth flow, which is F4 equal to 2. So I'm going to write it up here with the blue barrel. So we have right here we have 6 getting it from 5. So we subtract 2 from there. Subtracting 2 we have 0. And if we add it to the excess capacity we have 6. And then 5 gotten from 3. So we subtract 2 from the excess capacity there. And so we have 3, and then here we have 2, and the 3 is getting its own from 1, so subtract 2 from there, we have 4 here, and then right here we have 4. And so write out the rest, we have 8. This is our new network here, and then we try to see if we can label again. So trying to label this again, right here we can label 2 from 1. So we have 1 comma 1, which is the node, and there is the capacity. So try to label 3 from 1. So I have 4 comma 1, and then we check if there is any node we can label from 2. So you can't label 4 from 2 because here we have already exhausted everything here, and right here there's nothing left here in the excess capacity. So we'll try to see if we can label from 3. So right here we can label 5 from 3. So we have 3 here, and then we check this capacity and here which one is less. So we have 3 is less than 4, so write 3 here. And so we check again. We can't label from 4 because there's no 4 have not been labeled. and then we check 5. Can 5 label? No, 5 cannot label any other node. And so uh, we see that we cannot uh, label the sync nodes, and that is where we stop using the um, label algorithm method. And so we are going to calculate the total flow that we got using the label algorithm method. And right here, the first one we had the F1 we had 2, and F2 we had 4, F3 we had 4, and F4 we had 2, and the total is 12, which means the maximum amount of flow that we can pass through this network here is 12. And so after doing this, we can rewrite our network. Right here we have this network with the excess capacities, and I'm going to rewrite this here just with the actual capacity. So what it means is that right here we'll have 8, I'll have 4 here, I'll have 0 here, I have 4, 4, 2, 2, 6, and 4. So if we had this network like this, having these capacities at these various places, this is the actual capacity that we are supposed to have for this network so that we can maintain a maximum flow. So using this label algorithm does not just give us the maximum flow, but it also gives us the actual capacity that we should have in this network. So we are going to be doing another example on this.